You will spend roughly 6 years of your life dreaming, and you will forget almost every minute of it before your feet hit the floor. 6 years of your one and only life gone, and most of us can't even remember what happened last Tuesday night. I'm Otto, and tonight I want to figure out why your brain does this to you. Here's the part that surprised me most while researching this one. We only found out dreaming had a specific biological signature in 1953 when a graduate student named Eugene Aserinsky and his advisor, Nathaniel Kleitman, noticed rapid eye movements happening beneath the closed eyelids of sleeping subjects at the University of Chicago. Wake someone during that stage, and they almost always report a vivid dream in progress. Before that discovery, dreaming was philosophy and guesswork. After it, dreaming became something you could actually measure with the electrodes on a scalp. That single finding cracked the door open on everything I'm about to walk you through. Let's start with the theory that a lot of researchers think gets closest to the truth: threat simulation. A Finnish cognitive scientist named Antti Revonsuo proposed that dreaming isn't random noise, it's rehearsal. He studied dream content across cultures and found something strange. Most dreams aren't pleasant at all. They're full of chasing, falling, danger, conflict. Revonsuo's idea is that our ancestors, the ones sleeping in the open on the African savanna, benefited from a brain that practiced surviving predators and rivals while the body stayed safely still. A dream where you outrun a lion costs nothing. Getting caught by a real one costs everything. So natural selection may have kept the humans whose brains ran the simulation over and over every single night for free. Revensuo backed this up by looking at children's dreams too, since kids under about 7 face proportionally more real-world threats from animals and strangers than adults do in modern life. And their dreams skew even more toward monsters and chasing than adult dreams do. That pattern is hard to explain as pure randomness. It looks a lot more like training. That's a nice story about danger, but it doesn't explain everything. So let's move to the next big idea: memory consolidation. Sleep researchers like Robert Stickgold at Harvard and Matthew Walker, who wrote the well-known book on sleep science, have shown that your brain uses sleep to sort the day's information. Picture your hippocampus as a messy inbox by evening, packed with everything you saw, heard, and felt. During deep sleep and REM sleep, your brain appears to replay and reorganize those memories, deciding what gets filed into long-term storage and what gets tossed. Dreams in this view might be the strange, glitchy soundtrack playing while that filing system runs in the background. Studies on rats have even shown neurons firing in the same patterns during sleep that fired while the rat ran a maze earlier that day, as if the brain is rehearsing the route after the fact. Stickgold ran a human version of this with the video game Tetris. People who played for hours, including some with severe amnesia, who couldn't consciously remember playing at all, reported seeing falling geometric blocks as they drifted off to sleep. Their conscious memory had nothing to hold on to, but something underneath was still processing the game. Now here's where it gets emotional, literally. REM sleep, the stage where most vivid dreaming happens, lights up a part of your brain called the amygdala, which handles fear and emotional intensity. At the same time, the prefrontal cortex, your brain's rational, judgment-making region, goes quiet. That combination, a loud amygdala and a sleepy prefrontal cortex, might explain why dreams feel so intense and so illogical at once. Psychologist Rosalind Cartwright spent decades studying dreams in people going through divorce and depression, and she found that dreaming seemed to help people process difficult emotions overnight, almost like unpaid therapy you receive while unconscious. Matthew Walker has called REM sleep an overnight therapy session, where the brain revisits painful memories, but strips away the sharp emotional charge attached to them. So you wake up remembering what happened without it hurting quite as much. Not every scientist agrees that dreams carry deep meaning, though. Harvard psychiatrist J. Allen Hobson proposed activation synthesis, the idea that during REM sleep, your brainstem fires off essentially random electrical signals. And your cortex, the storytelling part of your brain, scrambles to weave those signals into something resembling a narrative. Under this view, a dream isn't a message, it's your brain's best attempt to make sense of static, the same way you might see a face in a cloud. The emotion might be real, but the specific plot, the flying, the missing teeth, might just be noise dressed up as meaning. There's also a newer angle worth knowing: the default mode network. This is a set of brain regions that switch on when you're not focused on any task, when your mind wanders, daydreams, or reflects on yourself and other people. Researcher G. William Domhoff has pointed out that brain activity during dreaming closely resembles default mode network activity while awake. In other words, dreaming might not be some separate mysterious system. It might just be your normal mind wandering process, running with the volume turned all the way up and the outside world locked out. So why do you forget almost all of it? This part actually has a fairly clean explanation. During REM sleep, levels of norepinephrine, a brain chemical tied to alertness and memory encoding, drop to their lowest point of the entire day. Robert Stickgold's research suggests that without enough of this chemical on board, your brain simply doesn't encode the dream into a memory you can retrieve later. It's less like forgetting and more like the recording, never fully saved. That's also why waking up suddenly, say to an alarm, gives you a much better shot at remembering you're catching the dream before the recording gets deleted. Then, there's the strange exception, lucid dreaming, where you know you're dreaming while it's happening, and sometimes can even steer it. Stanford researcher Stephen LeBurge spent years studying this and found something remarkable. Lucid dreamers show increased activity in the prefrontal cortex, that judgment center that normally goes quiet during REM. It's almost like a sliver of your waking, reasoning mind slips back online in the middle of the show. It's rare, it can be trained with practice, and it remains one of the clearest windows we have into how consciousness and sleep overlap. LeBurge even proved lucid dreamers could signal the outside world in real time, having them perform a prearranged pattern of eye movements the instant they realized they were dreaming, which showed up clearly on the lab's monitoring equipment. While their body lay still and their eyes, the one part still connected to conscious control, sent the message from inside the dream itself. Now, before all this brain scanning existed, ancient humans still had to explain dreams, and they took it seriously. In ancient Egypt, priests kept dream books, the papyrus Chester Beatty being one of the oldest surviving examples, listing dream symbols and whether each one predicted good or bad fortune. In Mesopotamia, dreams were considered messages from the gods, and the Epic of Gilgamesh is full of dream omens that characters interpret before major decisions. The ancient Greeks were split. Aristotle actually pushed back against the divine explanation, arguing in his writings that dreams were a natural product of the body and senses, not messages from anywhere sacred, which honestly puts him centuries ahead of his time. Later, Sigmund Freud famously argued dreams were coded wish fulfillment, a window into repressed desires. Modern neuroscience has largely moved past Freud's specific framework, but credit where it's due, he was one of the first to insist dreams meant something and deserved serious study rather than dismissal. What's wild to me is how much closer some ancient thinkers got to the truth than we give them credit for. They didn't have amygdalas or default mode networks in their vocabulary, but they understood that dreams weren't nothing. They were trying to explain a real, universal human experience with the tools they had: myth, symbol, and pattern. We're just doing the same thing now with electrodes and brain scanners instead of priests and omen books. So why do we dream? Probably not for one single reason. Your brain seems to be running threat rehearsal, sorting memory, processing emotion and wandering freely, sometimes all in the same 8 hours, and then deleting most of the footage before you even wake up. 6 years of your life, spent in a theater only you attend, most of it gone by breakfast. If your brain is this strange and this busy every single night, imagine what it was doing for the 200,000 years before REM sleep had a name. That's exactly the kind of question I dig into on this channel. So subscribe for more deep dives into ancient human life, the weird behaviors we inherited, and the science behind why our bodies and brains work the way they do. I'm Otto, and I'll see you in the next one.